Hello everybody and welcome to another C++ tutorial for beginners. Now in this video, what I'm going to be doing is showing you arithmetic operators. Now arithmetic operators are like addition, subtraction, increment, decrement, and the things you use on numbers, so floats and ints. So with that said, let's dive into the video. So I've got my starting C++ code defined, I have my main function, and what I'm going to start by doing is just listing out all of the operators that I'm going to show you. So I'm going to use a multi-line comment. Remember, that is the / asterisk and then asterisk backward slash. And these are the operators I'm going to show you in the order that I'll show them to you. So plus, minus, division, multiplication, and then increment and decrement. So plus plus means increment by 1, and minus minus means decrement by 1. I will show you that when we get to that. So what I'm going to start by doing is defining two variables. I'm going to say int x equals 8, and I'll say int y equals 9. Then I will say int sum equals x plus y. Now, when you're using arithmetic operators, make sure you understand the types of your operands. So the operands are just the things on the left and right-hand side of your operator. So an operator performs an operation on two operands. So in this case, x is an operand, y is an operand, and the addition sign here is the addition operator. So when I say int sum equals x plus y, my left operand is an int, my right operand is an int, and so my result is going to be an int. So it's very important you understand the types of your operands, because when you have different typed operands, you may have some type of errors. For example, you cannot add an integer to a string, right? That is an undefined operation because the operands are of different types. So anyways, let's just see out sum. Let's just make sure that this does actually work. And then I'll go through the other operators. Of course, addition is straightforward. It is just addition. So let's compile the program. I actually want to compile tutorial 5. And then let's run our program, and we see we get 17. The addition operator does work. Now, of course, we can chain these operators together as well. I could add, a 3 at the end here. So I say x plus y plus 3. C++ does follow the standard order of operations, and I will show you that later in the video. But anyways, let's compile this. Let's run, and now we get 2. Wait, why is it that we're getting 2? Oh, I keep compiling tutorial 4. Sorry, I want to compile tutorial 5. Okay, let's run this. There we go. So now we get 20. Awesome. So that is the addition operator. Now, of course, we have the subtraction operator. The subtraction operator could give you negative numbers. Negative numbers are valid in programming languages and in C++. So let's run this. We are going to compile. Okay, why do we keep compiling tutorial 4? I want to compile tutorial 5. Okay, run program, and there we go. We get -1. So addition, subtraction, pretty straightforward. Now let's move over to division. And sorry, what did I say? Division? I meant addition and subtraction. Okay, so anyways, we're going to divide two numbers now, x divided by y. So let's compile this, and let's see what we get. So notice that what I have here is I have 8 divided by 9. So take a guess at what you think we're going to get. I don't expect you're going to give me the exact fractional value, but what do you think is going to show up here? So let's compile this. Let's run, and notice we actually get 0 here. That's kind of strange, eh? Because we probably should have gotten a floating point value. 8 divided by 9 is not 0. We just know that is not the correct answer. So why is it that we are getting 0? So the reason we get this is because our left and our right operands are both integers. So whenever you perform an operation and both the operands are the same type, whatever your result is going to be the same type as both of those operands. So in this case, we have 2 ints, which means our result is going to be an int. So even if this division gave us like 0.87 or whatever the result actually is here, we're just going to get 0 because we're going to remove that entire decimal portion, because both of our types are ints. Now, even if I change the type of the variable here, so I change my sum variable to be equal to float, you're going to see that we still get the same thing. It doesn't matter if we change the type of this variable. We're not all of a sudden going to get the floating point result now. We are still going to get the integer 0 because both of our operands are ints. Now, let me show you what happens, though, when we change only one of these operands to a float. So as soon as we change one of these operands to a float, and we compile our program, so let's compile tutorial 5, and let's run it. Now, all of a sudden, we get the correct result. So as soon as you have one of your operands being equal to a float, that means that you are going to get a float returned. The reason for that is that the float has a higher level of precision than the int, and so to get a valid answer, you need to have a floating point result. So just keep that in mind. Whenever you have a float and you're using arithmetic operators, the result will be a float if it is a floating point result, right? So if it's just 1 or if it's just 0, regardless of the float or int, you're still going to get that. But if you could get a floating point value, like in this case, 0.8889 or whatever it was, you will get that when you have one of these floats. Now, when we change the other one to float, and then we change this one to int, I will show you we will get the same thing. It doesn't matter which operand is a float, as long as one of them is. So compile, run, we get the same thing. If both of them are floats, this is all good. So let's go float now. Let's run this. Okay, run program. But now what happens when I change the sum variable back to an int? Well, take a guess. But when I change this back to an int, and I compile, and I run, now we're getting 0. So what's happening here is that after we perform this division, there is like a 0.8, and sorry, this should be a bunch of 8s, 9 answer. So this will give us this x divided by y will actually give us the floating point answer. And then what happens is, since our variable is an int, we will need to convert whatever this answer is to an integer, which means remove all of the decimal places, and so we get 0. So that is why types is very important. That's why I stressed them a lot in the previous videos, and they're just going to become more and more important as we go through this series. So anyways, that is division. Now I will show you multiplication, which is an asterisk. So one single asterisk will multiply x by y. So let's go ahead and run this. We go G++, run program, 72. Now let's just make one of these like 9.5. Let's run and see what we get. We get 76. Let's make it 9.6. I want to try to get 9 maybe 7, something like that. So we get some floating point result. So that's G++, run program. We still get 78, eh? Is there it's because we have an int as the result. So let me change this to a float. I was trying to get a floating point result for the multiplication, but I had int as the variable. So let's do this, run program. There we go. We get our floating point result. So those are kind of the standard operators: plus, minus, divide, and then multiplied by. Now, oftentimes what you will do is you will store the result of a division or a multiplication or whatever in a variable, like we've done here. Now, let's say you just wanted to like add some number to a variable, right? There's multiple ways to do this. So in a lot of cases, you have some variable x, and you want to add 1 to it, or you want to add 5 to it. You want to add something to x, right? So there's a bunch of different ways you can add. First, you can say x is equal to, and then x plus whatever you want to add to it. In this case, we would just add 8 to x. You also can use this operator right here, which is called plus equals. So I say x plus equals 2, and then I see out x. You're going to see that we will add 2 to x. So let's go ahead and run this. Run program. We've added 2. So this is a way to add. When you say plus equals, this means whatever the value of x is, add 2 to it, and then assign that new value to x, which in this case is 10. Now, of course, you have minus equals as well. So minus equals will remove 2 from x. So let's run this. Run program. There we go. We get 6. You have multiplied equals, which is going to multiply x by 2. So let's do this. And G++, run program. We get 16. You have divide equals. I'm going to divide by 2. So let's have a look at this. G++, and then run program. You get 4. And then finally, you have increment and you have decrement. Now, what increment does, which is plus, is adds 1 to x. So if you just want to add 1 to x, there's kind of a shortcut that C++ has. Rather than writing plus equals 1, which is totally valid, you just write plus, and this just means add 1. So let's run this. In G++, run program, we get 9. So that is increment. This is decrement. This means remove 1. So let's try this. G++, run program, you get 7. So use whatever option you would like. The cleanest ones are usually to use increment if you're adding 1, to use decrement if you're subtracting 1, and then any other addition, subtraction, multiplication, you use the corresponding plus equals, multiplied equals, divide equals, so on and so forth. So we will continue in 1 second, but I need to quickly thank the sponsor of this video and this series, which is AlgoExpert. AlgoExpert is the best platform to use when preparing for your software engineering coding interviews. They have over 140 coding interview practice questions. Each of those questions have a detailed conceptual overview and code walkthrough that is in video format, so it can help you understand how the question is solved. With that said, check out AlgoExpert from the link in the description and use the code TechWithTim for a discount on the platform. Now, of course, you can also use these with variables, right? So if I have, say, something like, let's go int y equals 4, and then I'll say x plus equals y, and this will just add y to x. So if we do this, compile, run program, we get 12. So those are your standard arithmetic operators. Now what I will show you is how we can use these operators kind of in combination with each other and the order of operations for these, and then we're pretty much done for this video. Nothing super complex today. So there is order of operations in C++. Order of operations is just like, let's say I have some crazy equation or something. I'll just say int sum equals x plus y minus x multiplied by 7 divided by 3, let's go times 2 or something like that. So how do we know in which order we should do these operations, right? Because we only ever have 2 operands for each operator, so we're going to have to pick in which order we're going to be performing all of these operations. Well, we perform these operations in the following order. Some people have different acronyms for this. In my school, at least in elementary school, they called it BEDMAS, like this. Now, what this stands for is brackets, exponents, division, multiplication, addition, and subtraction. This is the order in which you perform all of these operations here. So you would start with anything that is inside of parentheses or anything that is inside of brackets. So if you put parentheses like this, then you will, parenthesize that part of the equation or the expression, and you will do this first. Then you have exponents. I haven't shown exponents. I'm not going to show them here. Division. So then obviously division, you're going to have multiplication, and then addition and subtraction. Now division and multiplication have what's known as the same precedence. This means that they can be executed in any order and it won't actually change the value of the expression. So you can kind of test this for yourself, but if you have something like 2 multiplied by 5 divided by 2, it doesn't matter the order in which you do this, you're going to get the same result. So if you do 5 divided by 2 first, you get 2.5. You multiply that by 2, you get 5. If you do 2 times 5 and then you divide by 2, you get 10 over 2, you get 5, right? So it gets the same thing. Same when you're doing addition and subtraction. So that is kind of the order of operations. So if you look at an expression like this, we can just C out x or C out sum and see what we get. So not in all capitals, in lower cases. Let's see. Compile, run, and we get -25. There you go. So that is the order of operations. I will kind of let you guys mess with this on your own because it's not too useful for me to just go through more examples of adding, subtracting, multiplying numbers. I'm not a math teacher, but I will show you one more operator that I forgot to show you, which is the modulus operator, which is something you may not have seen before. So the modulus operator is the percent sign, and what this does is give you the remainder of a division. Now, this is actually extremely useful in programming and just in mathematics in general, and let me just show you what I mean. So let's say we have 8 divided by 5. What I'm going to do is I'm going to C out x mod y. So this is going to take 8, it's going to divide it by y, it's going to take x, it's going to divide it by y, so 8 divided by 5, and then it's going to give me the remainder of that division. So what is the remainder when you divide 8 by 5? Well, the remainder is 3. The way you calculate the remainder is you figure out how many times this number right here, which is the divisor, goes into the numerator evenly. Then what you do is you multiply this number by the number of times it evenly goes into this number, and then you subtract the 2. So when we have 8 times 5, 5 goes into 8 one time. So what we do is we say 5 times 1, that gives us 5, and then we take 8, which is our original number, we subtract it by 5, that gives us 3, so our remainder for this division is 3. The most basic example is if we do like 3 divided by 2, well, our remainder here is 1, because 2 goes into 3 one time evenly, and then we have a remainder of 1 after that. So let's do this, 3 divided by 2. We're going to see that our remainder here, what is this saying? Invalid operands of type float and int. Okay, so this is interesting. It's a good error to run into, actually. This is telling me that I cannot use the modulus operator on operands that are different types. So what I need to do is I need to change this float to an int. So let's do this. Let's compile the program. Let's run, and then we get 1. Awesome. So now if I change this to 5, what is our remainder going to be? Take a guess. Well, it's actually going to be the same thing. The reason it's going to be the same thing is because 2 goes into 5 evenly twice, and then we have a remainder of 1. Now, if we make this 3, what is our remainder going to be? Take a guess. So it's 5 and then 3. Well, this is going to be 2. The reason it is 2 is because 3 goes into 5 evenly one time. Then we have a remainder of 2. Now let's just see what happens when we change these both to floats, because I actually forget what's going to happen here if this works or not. I think this should work, but let's see. Let's compile, and we actually get an error. So it seems like we cannot use float with the modulus operator. So yeah, it seems like we just cannot use floats with the modulus operator. I believe that's just something in C++. I actually don't know exactly why. I'm sure there's some mathematical reason with decimal points and overflows and all that kind of stuff why we cannot use this to get the remainder. But anyways, that is the idea. So hopefully that makes sense. This is the modulus operator. One small thing for this, you must make sure you are using integers with the modulus operator. You cannot use floats as either of the operands. And yeah, that's all I need to show you in this video. So if you guys enjoyed, make sure to leave a like, subscribe to the channel, and I will see you in another YouTube video.